So today it is our first webinar, and we are very excited to welcome you today. When I talk about we, that would be Sasha Butter, Rubberfab Europe's product manager, Chris Neufer, Rubberfab Europe's application engineer, and myself, area sales manager in Europe. So as an introduction to the company, I guess everyone is aware about Rubberfab, about what we are doing, just some introduction lines. Rubberfab has been around the industry since 25 years. It was established and founded in 1995, has been family owned and operated till 2016 when it was acquired by Garlock family of companies, incorporated into Garlock Hygienic Technologies. What you can see on this picture is Rubberfab's headquarter facility in Sparta, New Jersey, like 45 minutes northwest of New York City. And Rubberfab has been offering a full range of high-performance products dedicated to hygienic process industries such as pharma and biotech industry, cosmetic industry, food and beverage industry, but also adjacent industries such as the semiconductor industry, basically any sanitary industry out there. So we're not only offering tri-clamp gaskets, which we are most famous for, but also a variety of other products such as hoses, validation products, orifice plates, screen gaskets, etc. and so on. So ever since 2016, when Rubberfab was acquired by Garlock, we've come a long road, especially here in Europe, and I think we can be very proud of that. Today, the European team implies not only Chris, Sasha, and myself, but also inside sales at the European inventory, which is there for your consultancy, but also when you have any issue regarding orders, for example, we have for sure someone running the warehouse, and we've moving more and more into Europe with certification, regulation, with our product range. So I think we've done already some nice jobs in the past. So for today's presentation, I will just give you a few more information. The focus today is gasket selection and hygienic sealing criteria, as well as certificate and regulation. And I'm very sure that any one of you would gather a lot of new knowledge and will enjoy this webinar. So at this point, I'd like to share the screen or ask my colleague Chris to take over the lead. Thank you guys and enjoy.
So we will make kind of a head start into this now. I will give you a quick overview about how you could choose the right gasketing material. So now you should see the STAMP gasket selection. STAMP gasket selection stands for S, size, T, temperature, A, application, M is the media, and P is the pressure. Stamp selection is an easy selection and an easy technique where you can really choose very quick in a kind of coordinated way the right gasket material and the right gasket size. Because first point is size, and mostly you know from your customer, or you know what the customer needs from his pipe size or his flange size. So this is the part size S. Then next into the account, we have to take the temperature, and especially temperature range for the gasket, as the material like EPDM has to withstand the various temperatures in your system or in your process. Especially when you make cleaning in place or sterilization in place, temperature can vary quite a lot. And your gasketing material has to withstand all these temperatures. Next up is the application. You can read here. I can quick switch to laser pointer. Maybe you see it now better. Application. Do we have solid in this point is a bit misleading, but if we have a liquid, a gas, or a jelly similar product in our system, so maybe water or like a gas, like air, ozone, So that's the next point we have to take into account, because different materials like PTFE, EPDM, or even silicone handle these applications different. So that's what we have to think about. Next up is the M, the media. This is more detailed and more closely look into the substances we use. Do we have an oil? Do we have alcohol? Or even a neutral media? And for this, I can show you real quick a chemical resistance chart, which we have online on our website. So here it is. I hope you can see this now. So this is our chemical resistance chart at Rubberfab, where we have tons of different substances and how they comply with our main, let's say, our standard gasketing materials. They're rated A to D, and there you can really look quick. Is EPDM very good for bromine? Is it very good with a chromate acid? As you can see, in this case, it is C, so it's kind of the middle. And this chemical resistance chart is also a very good help for you when you make this stamp gasket selection. Last point is the pressure. You have to know, or you should think about the maximum working pressure in your system, but also you should really look into what other pressures can occur in my process. When we think about sterilization in place, for sterilization in place, we also need a pressure to kind of fulfill the steam sterilization. So this is the stamp gasket selection. It's really kind of a head start into this topic about choosing the right gasketing material. And what we have also for you, let's switch. What we have also for you are more documents which can help you to choose the right gasketing material. On this left side, you can see a screenshot of our validation brochure 2020. I can also show you this one. Should now be visible for you. So in this 8-fold, which we made, I think half a year ago and sent it out to you, we have also a lot of information about our products on this second side, where we explain our standard materials. And also you can find again this chart where we have a temperature range, very easy for you to watch. And we make some kind of short info about the recommendation of use. Taflex, continuous steam, that's a recommendation of use. So this document should be quite important one for you to watch, because there's also more information about our validation products, smart gaskets, biologic indicator, and much more. To get back to the information, to the presentation, what we also can offer you a very good overview is the product selection guide. I can also open this one for you, because the screenshot is not really a good quality, so it's always better to open this document separately. The product selection guide is a really quick and really good overview, again, about our standard gasketing materials like Gylon, BioPro Plus, Gylon BioPro, Buna, and all the others. In this product selection guide, the focus is a bit more on our standards and certifications. So you can see here all the standards that are right now very important for us. And you can quickly see if our material has this standard or this certification. Like for example, the PTFE has USP class 6. There's a yes, so this material has the standard. It's also a very good overview and a very good thing for you to watch and to look and to choose. If you're not sure, then you can look into the product selection guide and see exactly. So I always have to click the arrow here. So next up is the hygienic design. This is one of the main points we want to talk about today. Also later then to the standards and certifications. To say it before, this hygienic design is more a recommendation from our side for you. So what the most important points are for us in selecting gasketing materials, in selecting gaskets for your process. So we at RubberFab, we categorize the hygienic design criteria in 4 main points. The first point is the cleanability, especially cleaning in place and sterilization in place. Second main point is the surface nature and the properties of our surface. Next up is the dimension stability of our gasket when in the process, when in the flange, and the certifications and regulations. So we want to talk now about the first 3 points, and certifications and regulations is a separate point because it's so huge because of all the different standards, regulations, 3A, USP, FDA, and much more. So next up, the cleanability. The challenges at cleaning in place, you can see on the left. We need fast and effective cleaning cycles with high temperatures, high pressures and low rates, high chemical concentration, a low time and a low amount of cycles. To explain it, why we need high temperatures, we can see on the right side the sinus circle. This is a good example of the cleaning in place because we have 4 main factors in the sinus circle. The first one is time, the second one is mechanical, third one is temperature, and the fourth one is the chemical use. So the sinus circles works like this. It's a closed circle. Every part has it's like a cake, and every part is the same size at the moment. But I can switch real quick. What we need or what we want with this sinus circle, we want a low time amount. Why we want a low time amount? If we make a cleaning in place, we don't want to open our system, and we want a low time because low time means we can produce really quick again, and we don't have much cost for the process which is still standing at the moment. So we could say we cut the time shorter and remove this part. What we also want short is the mechanical use, because mechanical use means that we have to open our system and to clean mechanical by hand. Opening a system is always critical because we could really bring in the bacteria, bring in some other microorganisms. That's why we want to clean in place with a closed system. So that's why we want to cut the mechanical use as well short. So because we have to cut this short, and I said it's a closed circle, the chemical and the temperature has to overtake this part as well. So temperature is getting higher, chemical use is getting higher. As we said, high chemical concentration, which is here, and high temperatures, which is here. So the sinus circle is a very good explanation for how to make how to make cleaning in place very effective. Exactly. Then next up, there's the sterilization in place. Sterilization in place we can also describe again with the sinus circle, which is down here. I will switch real quick again to the laser pointer. We can also use the sinus circle, but this time in a different way because the time amount gets bigger. If we look on this side, we have the steam sterilization, which is the main sterilization type in the industry. And with the steam sterilization, we have a high pressure, a longer cycle, and a higher temperature. why do we have this? This is because at the steam sterilization, we can look on the right side on this chart. Here's the temperature, and on this arrow, there's the time amount. Steam sterilization is now, we have to reach a certain temperature, which is 121 degrees, and we have to hold this temperature for about 20 minutes to sterilize our whole system. In this 20 minutes, there's happening inside of the process a lot, but outside nothing. So this is kind of a bit dead time. But we need this time to sterilize really our system. After this 20 minutes, the temperature is dropping down and we can produce again. So if you look back to the Sinus circle really quick, the time amount would be bigger. Mechanical use would be maybe retightening the clamps again. Temperature would be high and chemical use would be low because it's a steam sterilization. If we look quick above here, we can also see fast and effective sterilization types, some others. Irradiation is a bit misleading in this case. Irradiation, a whole plant or the whole process would be very difficult, but it could be a type for maybe your gaskets. The gasket irradiation could be a point in here. But we have also chemical sterilization and sterile filtration, which is also quite a bit misleading because if your plant is very, very big, sterile filtration would be maybe not the best solution for you. Exactly. The next slide you can see here. In this picture, we can see different particle contaminations. It starts with a human hair, which is quite very big in this comparison and goes all the way down to E. coli bacteria. This chart or this slide should show you that there's always a limit what the human eye can see. And we tend to say that a surface is dirty when we can see something like dust on our window shelf or something. But there's always a limit, like I said. And this limit is right at the dust particle to the grease particle in this point. So like I said, we tend to say something is dirty when we can see something like dust. But we always tend to say when we don't see something that there is nothing. But this is not the case. The really bad bacteria, the really dangerous bacteria or yeast or E. coli, they are so small you can't see it with the human eye. So there you should always think, even you can't see it, there can be something. And that's why we have this slide inside. So you kind of get a reminder, visible and invisible, don't care. Invisible is the dangerous part. That's why we need sterilization in place and cleaning in place on a high level and a good process. Exactly. This was now the first part, the cleanability. Now we get to the gasket surface. As we can see on the left, if we have a rough surface like you remember steel maybe under a microscope, you can see it looks like the Grand Canyon. And because if your surface looks like the Grand Canyon under a microscope, it's very easy for bacteria or for particles and microorganisms to get hold into these deep spaces or the mountain deep spaces on your gasket surface. A smooth surface, therefore, eliminates cracks and creases, as we can see here. And it's very, very difficult for particles to get hold on a smooth surface. And as you can see, also on this, sorry, a microphone. Yes. So what we want to say with this slide is our materials have to be very smooth. Our gasket surface has to be very smooth. And therefore, we have to choose, when you think about a gasketing material and gasket surface, that we have a low rate of cracks and creases, or like these mountains, like I said. This has to be low. Also, a smooth surface is less energizing for the system, because when you have a smooth surface, your process can run through. If you have those mountains, it's very energizing. Your system has there kind of a hold or a stop where it always tends to press against. Yes. Next slide is the biofilm. The biofilm is one of the most insidious uses that exist. On a biofilm, quick explanation for this, the dirt adheres to a very smooth surface. As we see before, the biofilm is like of bad contamination that even can get hold on smooth surface. When the biofilm, or when those particles get hold on the smooth surface, it's creating more contact surface, more contact space. With these particles. With this, the biofilm grows. This is the growth period, the second, and the biofilm gets bigger and bigger. And now it's not possible to say exactly when a part of this biofilm adheres and the contamination will get released. So the biofilm can be in your system for quite a long time, and you can't detect it because the biofilm gets hold and just grows, and it's not removing. But like I said, the biofilm is an insidious use, so there could be the point where a big part is breaking out of this biofilm and get back into the process and into the end product. Like I said, the recognition is enormously difficult and can only be detected when you control or check constantly the colony forming units. And the colony forming units can detect a biofilm only if there's a removal on it. So if the biofilm gets hold and is just in your system and nothing breaks apart, you can't detect it. So the biofilm you should prevent right from the start. And therefore, we have to take into account our smooth surface and also the cleanability of our gasket. If the cleanability is high, the surface is very smooth, a biofilm can't even get hold and grow. Another factor in this point with the surfaces is the surface energy for different materials. If a material has a high surface energy, the material really tends to attract and adhere particles, as you can see here, because it's kind of like a magnet, a strong magnet, which really adheres the particles to get hold on it. And even a smooth surface can get a very high surface energy. A smoother surface tend to get this sometimes. Therefore, you can avoid this if you have a low surface energy material. These 18.5 Newton meter at 20 degrees is for PTFE. And so PTFE has a very low surface energy in this point and a very smooth surface compared to some other materials. So what we want to say with this surface energy also reduces is no intrusion and no recesses. So the dead spaces don't get created, which we come to next to explain. And we want to reach an anti-stick surface, like ice on wet ice. If you have seen it, if you have ice, you put water on it and put another wet ice or ice part on it, a block. You can move it very easily. And this is an effect we want to reach because it's an anti-stick, a cannot sticks effect. Yes. So when we come to the next part, which is extremely important for us at RubberFab, is the dimension stability. Like I said, when we come to the intrusion and recession, we differentiate between these two parts, intrusion and recession. And what we want to reach is the smooth bore. You can see here, this is the perfect way to install your gasket, and we could say the only way we want to have it. So let's get back to the intrusion. If we think about EPDM, FKM, and silicone, where elastomers, these materials tend, if you give them too much pressure, maybe an over-tightened clamp from the outside, they tend to intrude into our process. The recession could be PTFE materials. Not only PTFE, other materials can tend to this too. If you give them too much pressure, they kind of move backwards into your flange. These two parts are very dangerous, and you should really avoid these intrusions and recessions, because you create always dead spaces. And you create these dead spaces with the recession inside of your flange and with the intrusion behind your gasket and in front of your gasket. So in the first case, we make it really quick. Again, this is the optimum. This is the perfect way to install your gasket. And the second, the recession, you can see they're already kind of deposit some dirt, some microorganisms. And the problem with the recession in this case is the cleanability of your gasket gets lower and lower, because it's very difficult, even for cleaning in place and sterilization in place, to remove the parts out of this area, because it's not really in your flow. It's kind of deposit outside of your flow. The intrusion is the same. The particles can adhere in front of your gasket, but you see more behind your gasket. This could be because if you have an intrusion, you can see the dimension stability here. The intrusion is always disturbing of your process flow. So the intrusion causes a narrowing of the pipeline. Your steam kind of gets smaller, because when we think at the orifice plates with the drills, we also make a narrowing of our process flow. And the same is the intrusion, kind of. Behind the intrusion, behind our gasket, there occur these kind of turbulences, and these turbulences bring the material, bring the microorganisms, particles and everything behind your intruded gasket. The problem now with this is also cleaning in place, sterilization in place. If our steam is already disturbed because of this narrowing, it's very difficult for our cleaning in place to reach it. You may now think there is these turbulences, why they don't clean the gasket, why they don't clean this part again. It's very difficult again for these cleaning in place to reach all of these parts behind your gasket, also in front of your gasket. And that's why it's nearly impossible to clean it. The intrusion is also, like I said, we need longer cleaning cycles. With longer cleaning cycles, we could get rid of these particles again, but it's not 100% sure if you can remove all. These parts, the intrusion and recession, they can always tend to bring a cross-contamination. If we produce first orange juice and second tomato juice, we can get a cross-contamination if these particles stay in our system. Also, the restriction of flow, like I said, the narrowing of the pipe leads to a bigger speed, to a turbulences, which we don't want to create without a reason into our system. And the higher velocity, like I said, is created. The next point is the sealing points. The sealing points you can see in this picture with the green arrows and the black arrows. We say that here could be a potential risk that we get our process fluid inside, that we get microorganisms inside, that this is sorry, a problem. Now here's the main sealing point in our system. It's right between flange and gasket. Why is this the most important sealing point inside the process? It's because if this point is not 100%, like we say, sealing, material or our process fluid, like I said, can go inside this part. If it goes inside this part, it's nearly impossible to clean it correctly, to clean it 100% sure, or to sterilize it again. So our process fluid and the particles, microorganisms, can grow in this part. They always can go back into your process, which would run here. So the most important sealing point right here should be always sealed 100%. Therefore, the gaskets tend to be a little bit smaller, some of them, some a little bit bigger, because when you seal or when you tighten your clamp outside, we saw the recession, we saw the intrusion. If you tighten your clamp outside, you always move your gasket a little bit to reach the exact sealing point here. Another big important sealing point is outside. Outside is it because if you have outside the sealing point, not really like this point, material or some contamination can get from the outside atmosphere inside your process, because the other way is possible as well. So the sealing points, it's like I said, to prevent leakage and entrapment in this part. And we can see the second big point. In our process, we have different temperatures. We have sometimes a sterilization in place with chemicals. These temperatures and chemicals cause a swelling of the gasket. So the gasket is expanding and contracting. It's getting bigger and smaller, like I said. And this moves our sealing point, or could be possible that our sealing point moves because of the swelling and the contradiction. So it's always a reminder to think about the material of our gasket and to choose the right material for the right temperature and for the right chemicals to maintain the sealing point. Also, the compression of the gasket is critical to seal. Like I said, over tightening and under tightening your clamp could be very dangerous because you cannot reach your sealing point, your perfect sealing, if you have not the right compression. So to give you a quick summary of these points we talked about now, we talked about cleanability, cleaning in place, sterilization in place. We saw the Sinner circle, which is a good instrument to explain this. We talked about surface nature and properties. We don't want a rough surface, we want smooth surface with a low surface energy. We talked about the dimension stability. And what I have also for you, it's another document which we created, which you can see here. This is a white paper about sealing design criteria, which are talking about these main points, these 4 main points we choose at Rubberfab, which is our recommendation to have a look into, to think about. As you can see here, there's also surface energy, intrusion, recession explained, and maintenance with torque tees. These documents are for share, and we will share it with you later. So We didn't talk about certifications and regulations so far, and this is our next part. But now I get back to Dominic, who is explaining this part quick.
Thank you very much, Chris, for sharing this very important aspects and notes. And the audience, I hope that you picked up some good knowledge and refreshed these industry terms as well. So as Chris mentioned, this next part is focused on industry certificates and standards. So we have multiple standards for sure, multiple regulations that we need to stick to in the industry. And I know that every one of you is aware about many of the standards. At least we know that in our industry, in pharma and biotech, 3A, USP, FDA is most important. But what we sometimes don't know what this implies. So just give me a second. I want to switch to the next slide. Here we go. So this is an overview about many of the regulation standards and associations we are faced with from day to day. There are international standards, there are local standards that we need to stick to, like FDA, USP, which I mentioned. There are standards like ASME DEAN and so on. We don't want to go into the detail with all the standards and regulations, but we picked the most important. During the next slides, it will be Sasha Butter, who will focus on the EC 1935-2004 regulation, for example, as the Chinese regulation as well. And afterwards, it will be Chris once again to go into the USP, FDA, and 3A standards for your better knowledge. Okay, please enjoy.
Thank you, Dominic, for the introduction of our next chapter, Industry Standards. Welcome everyone, good morning or good afternoon, depending where you are right now, and thank you for joining today's webinar. I'm very happy about the number of participants we have today and would like to continue with the next section of today's webinar. So far, Chris has talked us through the most relevant hygienic design criteria to consider when choosing materials for the most critical food and pharma applications. The technical application knowledge of the supplier is therefore of very high importance when choosing a suitable sealing solution for end-user applications. Another aspect that defines the quality of a sealing solution is the level of compliance the products are qualified and tested for. But before we continue to discuss some of the most relevant industry standards, I want to give you a short overview of our in-house testing capabilities. Being part of the Garlock family of companies, Rubberfab has access to the global expertise of our material engineers, as well as the multiple in-house testing capabilities, like, for example, our chemical lab. Our chemical lab specializes in the characterization and analysis of fibers, fillers, and of course polymers for non-metallic gasket and sealing materials. This lab is also used to conduct immersions of samples in corrosive or toxic chemicals prior to testing in the physical lab. And also it serves as a venue for screening new materials for possible use in gasket and sealing compositions. For example, extraction testing according to FDA. Our compound lab focuses on micro-scale rubber production. This is a 1200 square foot lab, and it is used to produce small batches of experimental or custom-made compounds and to study the results of small changes in formulation or processing. In our physical lab, we specialize in testing physical properties of raw materials and polymeric composites, like for example rubber materials. The physical test lab has the ability to test materials in many different environments and liquid media. For example, we can perform testing of tensile strength, we can do compressibility testing, recovery testing, and so on. In our functional lab, we can conduct performance testing and we can characterize both static and dynamic sealing products. Sealing products can be evaluated under normal or accelerated operating conditions, utilizing standardized or customer-specific procedures. For example, steam in place testing according to ASME BPE standards. But in addition to the in-house material testing capabilities, Rubberfab is continuously testing and improving the level of compliance for our sealing materials according to the latest industry trends and, of course, regulatory requirements, using official external laboratories and testing facilities. The overview I'm going to show you now categorizes some of the most commonly required industry standards by their origin. For example, on the US side we have the Food and Drug Administration, the FDA. Then we have the USP, the United States Pharmacopoeia. We have the 3A Sanitary Standards, and we have the ASME BPE, the ASME standards for bioprocessing equipment. In Europe, we have the EC 1935, symbolized with the glass and the fork. It focuses on food contact materials. We have the BFR, the Institute for Risk Evaluation, which is fairly similar to the FDA from the US. And we have the EHEDGE, the European Hygienic Engineering and Design Group, which does similar work as the 3A in the US. In Asia, we want to focus also today on the Chinese food contact regulation, which is symbolized by the chopsticks and spoon symbol. Before we talk about the specific industry standards, I want to continue by getting into the terminology of leachables and extractables. The reason for that is that a lot of material testing evolves around extraction testing and extraction analysis. That means that you will encounter the terms extraction and extraction testing multiple times connected to different industry standards. So let us look at the definitions for extractables and leachables first. Extractables are chemical compounds that are extracted from a material under extreme conditions. So extractables are chemicals that can be removed from final articles when you use elevated temperature, different solvents, pH values and exposure times. So under extreme conditions, extractable studies are performed, and usually after the extraction part, the analysis is followed by highly sensitive analytical methods to define the quantities of the substances that have been extracted. This analysis is usually followed by a toxicological evaluation. That means the extracts obtained from the extractable study are evaluated for their toxic effect, and the laboratory prepares a detailed list of the extractables with an assessment of their toxicological and general toxicological properties. This is, for example, done in USP6 testing. Another term maybe not so often used as the term extractables is the term leachables, but I want to show you the difference between those two terms. By definition, leachables are chemicals and compounds that are released from materials under normal environmental conditions, for example during the shelf life of the product. So leachables are also chemicals or substances that can migrate out of materials. However, leachables, the word leachables is used when we're talking about substances that leave the material under normal conditions. For example, typical exposure times and/or temperature. And like I said, I wanted to define those two words, and especially the word of extractables or extraction, because a lot of testing that we have to perform to fulfill the industry needs and requirements are extraction tests. This is an overview of the most common test standards involving extraction studies. You see that we have a color scheme, and when you have a look at the bottom right box, you find a legend of what the different colors stand for. You will find that the gray color stands for guidelines that are specifically for elastomers. So, for example, the FDA chapter 21 CFR 177.2600, it is the commonly known FDA regulation for rubber articles. The green boxes represent guidelines for PTFE and elastomers. So for plastic materials and rubber materials, like for example the USP chapters 88 and 87, those standards and more specifically testing according to those USP chapters can be performed for rubber and plastic materials, so for PTFE or elastomeric sealing materials, for example. We also have a blue box. It contains guidelines specifically for PTFE. Here we have the FDA standard for perfluorinated hydrocarbons for the PTFE side, the FDA chapter 21 CFR 177.150, and it is a comparable guideline to the rubber guideline. It also contains a positive list of substances that are generally regarded as safe by the FDA, and it also, similar to the rubber guideline, it contains extraction testing. Another guideline we see on this overview is the EC 1935 and the GB 4806.1. Those are guidelines for food processing, for food contact materials, and the EC 1935 is the food contact regulation in Europe. It contains specific testing for plastic materials, but only for plastic materials, and the GB 4806 is the Chinese food contact regulation, and it contains testing portions for both plastic materials and rubber materials. Those two food contact regulations we want to discuss a little bit more detailed right now. Let's start with the European Food Contact Regulation, the EC 1935, from the year 2004. In the European Union, the general requirements for all food contact materials are contained in this EC 1935 guideline from the year 2004. And sometimes it is referred to as the framework regulation. Specifically, high practical relevance is Article 3 of this guideline, and it specifies also the purpose of this guideline and states that food contact materials must not endanger human health, bring about unacceptable change in the composition of the food, or influence the organoleptic properties of the food. So that means that the food contact materials may not change the taste or odor of the food products. In other words, we don't want our food product, for example milk or orange juice, to taste like the gasketing materials or other components of the manufacturing process. The second article that I want to highlight today is Article 17, and it is of practical importance as well because it covers the traceability of a material through all stages of the manufacturing process, but also all the way to distribution of the products as well. And the benefits of traceable products are to protect public safety. For once, traceability reduces product fraud, which poses a risk to the public, but it also allows for quick and efficient product recall, reducing the risk that defect products can have a negative effect on public health. Traceability is also very important for manufacturers and suppliers, and it helps businesses manage emergency recall situations. You can find those materials in Annex 1 of the regulation, which I want to show you briefly right now. So this is the European guideline EC 1935. You can find it on the internet in its latest version, and you can find the already mentioned articles in here, but when you scroll all the way down to the annex section, you find also the list of materials that are covered by the EC 1935 guideline. We'll have a look at that later on again. Another guideline to consider when talking about the framework regulation is the Good Manufacturing Practice, GMP. Like I said, GMP stands for Good Manufacturing Practice, and in order to prevent the endangerment of human health, Article 3 of the Framework Regulation states that all food contact materials, like for example gaskets or hoses, other products that are in direct contact with food, they all shall be manufactured in compliance with Good Manufacturing Practice guidelines. However, I must say that the GMP is relatively vague and unspecific as to what kind of specific measures a manufacturer or supplier needs to implement to ensure safe manufacturing practices. Therefore, it can only serve as a rough guideline. And the specific measures to ensure the production of safe products must be defined based on the specific industry needs and based on the products that are manufactured, depending on their purpose and where they should be used. It is recommended to apply additional GMP standards, like for example, according to FDA, to get more specific input on what you need to do as a manufacturer or supplier to ensure that your products are safe and do not endanger human health, as demanded by the Framework Regulation 1935. The third pillar of the EU framework for food contact materials are the material standards, or the so-called specific measures. The material standards generally deal with the actual product and material testing and describe the test methods applicable for each group of materials covered by the Framework Regulation. So far, special testing standards exist only for the following substances. We see those substances in the left box, and we see that plastic materials are, for example, included, or ceramics, so we have specific testing standards for those materials. For those substances on the right here, we currently do not have specific testing standards on EU level. Let us focus first on the specific testing standards for plastics, the EU 10/2011. It outlines the requirements of the composition of plastic materials that are intended to come into contact with food. It contains what is called the Union list of various monomers, other starting materials as well, production aids and additives that may be used in the production of polymers. So, for example, PTFE gaskets would fall into the category of plastic materials. The 10/2011 regulation provides specific migration limits for materials. The specific migration limit is the maximum permitted amount of a substance that can be allowed into the food. This limit should ensure that the food contact material does not pose a risk to the health of the consumers. So let me show you the EU 10/2011 guideline quickly. I want to show you the positive list. Here we find, like I said before, all substances, all monomers that can be allowed in the production of food contact materials. So for example, if I Google tetrafluoroethylene, we find the monomer of PTFE, and we also find the specific migration limit. It is 0.05. I think it is milligrams per kilogram. Let's see. Correct, milligrams per kilogram. And we find those limits also for other substances that are in this positive list. Let's come back to the presentation. In addition to specific migration limits for certain substances, as we have seen for tetrafluoroethylene just now, there's also an overall migration limit. that a finished article must meet when tested with appropriate food simulants related to the real use conditions of the product. Food simulants for product testing are, for example, ethanol, olive oil, and acetic acid. At present, there's no specific measure, no specific material standard available for food contact materials made out of rubber, for example, or glass, metals and alloys. But of course we have a closer look on the rubber side, because a lot of gasketing materials are manufactured from rubber materials. So in this case you have to demonstrate conformance to Article 3 of the Framework Regulation another way. And you need to prove that the materials are safe to use in food contact applications. For example, you can use various other regulations or guidelines. Those include the German BFR guideline recommendations according to Chapter 21 and 15, and the FDA regulation for rubber materials, the FDA 21-177.2600. The EC 1935 framework also covers the restriction of use of certain epoxy derivatives in materials and articles intended to come into contact with food, by referring yet to another regulation, the EC number 1895 from the year 2005. However, you must only consider this guideline when one or more of the substances listed here, for example nitrosamines or bisphenol A, are used in the formulation of the food contact materials. I want to also talk a little bit about the China food contact regulation, and what you can see right away when you compare those two regulations next to each other. You see that both of them are framework regulations, and that the China food contact regulations are patterned after those of the EU. So for example, we have the framework regulation EU EC number 1935, and we also find general standards, framework standards on the China side. In the EU we saw that there's a EU regulation for good manufacturing practice number 2023 year 2006, and also on the China side we find regulations that cover specifically the manufacturing practices. And finally, on the EU side we have a specific measure, a test standard for plastic materials, EU number 10/2011. We also have specific testing standards for other materials, and the same thing applies on the China side as well. The Chinese food contact regulation implies specific product and material testing standards. So let's have a closer look. Similar to the EU food contact regulations, also China developed its own food contact regulation. The GB 4806.1, for example, serves as a general safety requirement for food contact materials, requiring that substances must not endanger human health or affect the organoleptic properties of the food, very similar to the EC 1935. The GB 31603 specifies the basic hygiene requirements, and it also contains management guidelines. So for the facility, your staff, all stages of raw material procurement, of processing, packaging, storage and transportation. So it specifies all these things that you need to consider during the production of food contact materials. It is also a lot more specific than the EU regulation for good manufacturing practices. The GB 9685 specifies a list of additives that are permitted for use in various food contact materials. And then we have the GB 31604. It consists of several parts that outline testing protocols, specific testing protocols similar to the EU food contact testing. The food contact materials are tested in various food simulants with both overall and specific migration limits, very similar to the EU testing. The two most common regulations that are pertaining to sealing products are the GB 4806 for plastic materials and of course the 4806.11 for rubber materials. All of our Toughflex products as well as the entire ASME range of our tough steel products have recently passed material testing and are now in full compliance with both European and Chinese food contact regulations. I want to thank you all for your interest and would like to give the word back to Chris, who will guide you through some more industry standards. Thank you.
Yes, thanks a lot, Sasha, for the explanation of these two very important standards and regulations. I will now continue with sharing my screen about the FDA. Should be visible for you now. So the FDA, I'm not sure if everybody knows what FDA stands for. FDA is the Food and Drug Administration and is a government agency within the US Department of Health and Human Services, as you can see here on top. The goal of the Food and Drug Administration is also in this text a little bit. It's to ensure the consumer's health and safety while producing food or cosmetics in your process, in your plant. The Food and Drug Administration has quite a lot of sections and quite a lot of codes, as you can see. The most important for us is the Title 21. The Title 21 is, as I said, a lot of sections from 174 to 170.30. And in our case, the most important two of these codes or standards, as Sasha mentioned earlier on the leachables and extractables, are the 2600 and the 1550. 2600 therefore is for rubber articles intended for repeated use. So if we have an EPDM gasket and we want to use it repeatedly into our process, the FDA covered the EPDM with a test. This testing is also an extraction test and is with different medias. So you can think about a glass and you have your EPDM gasket or a part of it, and you just throw it inside of this glass. And inside of the glass is maybe water, ethanol, or hexane. So there are different fluids inside. And then there's made a test with a different time. In this case, it is 2 hours. And afterwards, you analyze the water. What gets out of your gasket? And is this what gets out of your gasket, this substance? Is it in a limit, within a limit? So you can say afterwards, this EPDM gasket has get out a substance and is good to use for repeated use into a process where we process food or cosmetics, to say this. The 15.5, therefore, we can see is for perfluorocarbons like PTFE or FEP. So to say it very simple, the 2600 is for elastomers, FKM, EPDM, silicone, this area. The 15.5 is therefore more for the PTFE. The 1550 has also extraction testing, which is done also in 2 hours. But the main difference is, if we quickly jump back to 2600, for elastomers, you can also make a second testing, which is done in 7 hours. So the 15.5 is making these basic testing with 2 hours, and is also making an analysis what gets out of your gasket, what substances can be released over a certain time. To say about this testing, we Sasha mentioned the positive list, and overall about the testing of the FDA is always the first step an analysis of this testing of these substances of this positive list, which I can share with you. I think it's difficult to read for you, but I just want to show you the FDA is a very transparent and a very open, let's say, regulation. So everything you want to know about the FDA can be found online on their website. And what we have here is the Title 21 and the Section 2600 for the rubber articles intended for repeated use. So if I scroll down now, don't be worried, there will be a lot of different substances, chloroprene polymers, all the way down to the diculum peroxide and all this stuff. So this is the positive list of the FDA. To understand this a bit easier, these substances in this list, they have all this certain limit. So if we can see, all accelerators maybe should not exceed 1.5% of the weight of the rubber product. So this says all the mentioned substances should be not exceed this percentage after the test is done and the analysis is made. So when we go back to the presentation, should be here. So this test with the positive list is done first, and then it goes specific to what material we have. If we have elastomer, we go with 2600. If we have PTFE or FEP, we go with 1550. So in the past, we had, when you think about our certifications, if you saw one, or our certificates, this was intentioned or mentioned in the text on our certificate, where we said this EPDM has 2600, and now you saw what's kind of behind this number. Also, when you think about certification, the FDA is a regulation. You should verify your products once. So it's kind of, we send our EPDM to a testing laboratory. They test after the FDA standards, after the regulations. And after the test is done and it was successful, we can say this EPDM product is FDA 2600 maybe. So there's no continuous testing on the FDA. The test has to be verified once, and then we can make the certification by ourselves. So we can send you the certificates. That's something to the FDA. The next part is the USP, the United States Pharmacopoeia. The USP, as you can see, is a non-profit organization that sets standards for the identity, strength, quality, and purity of medicines, food ingredients, and dietary supplements, which are manufactured and consumed worldwide. The USP, we maybe all know, they have different classes, which goes from 1 to 6, which the class 6 is the strictest one of those. So we don't kind of have to talk about the class 1 to 5, as our products at Rubberfab are always USP class 6. This is because if you have the strictest class or the highest class, you don't need the others. Simply as this. So the class 6, as you can read in this text, is a certificate which is expected to be more likely to produce favorable biocompatibility results. So the compounds must be made from ingredients that are clear in history and meet the tight requirements. Now the USP, as we also saw in the leachables and extractables, they make also testing, and a very strict testing. This testing is in 2 parts. These 2 parts are in compliance with elastomers and also with thermoplasts like PTFE. So we can test EPDM and PTFE with both of these classes. To have a closer look on part 87 testing, which is also called cytotoxicity, is an in vitro test. So this in vitro test, I can show you one of the test examples for EPDM. So Sasha showed you already the testing about EC 1935, and this is a test of the USP. When we scroll down, we can see there's the table of contents, which is, I would say, important for us. For you as a customer, it's of course easier the study summary. You want to know, is our material or is the material of rubber fab in compliance with USP 87? So the study summary gives you an overview about this and says that based on the criteria of the protocol, USP 87, the test article meets the requirements. So in this test, there are a lot of information. There's an explanation, a very good explanation of the test, which is done in vivo. But the result remains as that the article, the EPDM in this case, meets the requirements of the USP 87. To switch back to the presentation, there's also Class 6 Part 88 testing, which is in vivo, the animal testing. I don't want to show you pictures of these testing, how it is done, but I can also show you a test report in a second. In the testing of USP Class 688, we make also an extraction test, and because the animal test, it is a implantation test. So we implant a part of our gasket, if it's silicone, into a live animal, and we study what happens, what is kind of extracted and how the animal is behaving. So to show you also a test report for this, I have a silicone test where we have again the table of contents, and you can see here in this first page or table of contents, this testing is, let's say, bigger than the 87, but both are the same important, of course. But it is bigger because the explanation of how the test is done, how the injection of this test is made. So again, this is much bigger than the 87, but the same important. There's also, if we scroll down, of course, the summary, which would be maybe for you the most important. And also here we can say, based on the criteria, our silicone would meet the test requirements. So for us, it's important to understand this testing, which is done at USP, also at FDA, and we will get to 3A now. So we have to understand all of that. For you, most important is our rubber fab products have USP Class 6, 78, and 88. To say again for the 88, it's also important, as we see here, the temperature, because there's a small difference. The temperature of USP Class 6, 88 can be done with 70 degrees or with 121 degrees. Most of our products here at Rubberfab are tested at 121, which is the higher temperature. And for that, it is the kind of complete 88 testing. Now, if we switch back to the presentation, we can go to the 3A Sanitary Standards. We talk now about EC 1935, the Chinese regulation, FDA and USP, and all of these regulations and standards are going more into the direction of biologic testing, of good manufacturing practice. The 3A sanitary standard, therefore, is more going into the direction of design and let's say, the mechanical and elastomeric properties of gaskets. To say something about 3A real quick, it's also an independent, not-for-profit corporation. And it's, like I said, is about the equipment design for food, beverage, and pharmaceutical industries. As we can see here, the goal of the 3A is protect consumable products from contamination and ensure that all product surface can be cleaned. This also means, if we think about a closed connection of a pipe, this also means the outside, like our clamps, how they should be designed and how they should be cleaned. It's not just kind of inside of our process, it's not just the gasket, it's the whole complete standard. The 3A has also two standards which are, let's say, more important for sanitary gasket than the other standards. The first standard is the 1803, the elastomer seals. So you can see we separate here again. When you look down, 2027 is for PTFE. We separate again elastomer seals and PTFE, thermoplastics. To say to the 1803, the elastomer seals, there are also 4 classes made. Class 1 to 4 is a quick explanation. The class 1 is kind of the best category, and the class 4 is the lowest. But for this classification, it's just made about hardness shore deviations, weight gain, and volume change. So if you look now in the 3A 18.3 testing, this testing is about, like I said, the physical properties testing. And testing therefore the hardness, the shore A to R, tensile strength, and the elongation of our products. And out of this test, with testing for the hardness, you can say you have class 1 or you have class 4. This is kind of the difference in this point. What is also tested in 1803 is a heat aging test, which our products or our materials are aged for, let's say, 166 hours at 100 degrees Celsius in this case, in an air oven. And after these 166 hours, we can say how our material is kind of aged under these temperatures. And there's also a hardness test fulfilled at the end of this heat aging test to see what's the difference at the start and at the end of this testing. Then the third test of 1803 is a fluid immersion test, where the testing objects are immersed 22 hours with various temperatures in the various fluids. And this is again quite similar to the to the FDA, for the FDA testing, where the testing objects, where our gaskets are again put into a glass with different or with various fluids over a certain time and temperature. And afterwards, we get the test object out, make a hardness test, make a weight change test, and with that, a volume change test. So to summarize this short, the 1803 is a lot of testing about how the products behave with different fluids and how they should be designed, hardness, how the compound should be made. To go to the 2027 for PTFE, there's also a test. We can call these products, if you see here's just perfluorocarbons, this sanitary standard 2027 could be called a multiple use product test for plastics. The testing is a bit similar to the 1803. It's also a fluid immersion test. So we also put the gaskets into a liquid, let it stay there for 7 days, sorry, at 70 degrees. And afterwards, we make a cleanability test. So let's say we put it into, let's say, water again, put it out and make a cleanability test afterwards. This is also a big part of 3A. They also say, as we can see on top in the goal, that all product surface can be cleaned very easily. So this is a quick overview about the 3A in this case. So the next one is the plasticizer free, and especially phthalate, bisphenol, such substances. And as phthalates are suspected of influencing the hormone balance of humans and can cause various types of damage to organs, we have to make our products, our compounds, we have to manufacture them without plasticizers, without phthalates, without bisphenol. And especially we have to carry out, let's say, testing that the substances we use in our compounds are not kind of creating plasticizers, as plasticizers are not just substances that are put into a product. Plasticizers, and especially phthalates, can be, if you make this product, they can be kind of developed out of different substances. Plasticizers, we know they are sometimes in plastic bottles or in children toy, which is very dangerous, and they're used therefore as solvents. Sometimes are in cosmetics too, or in fragrances. But the problem with plasticizers is that they are reproductive and they can develop toxicants, and that's why we here at RubberFab make our products, make our compounds without plasticizers, and we make sure that they don't develop. So the next step, which is quite close to plasticizers, but a different section, is the ADI free especially. The concern here is that animal divided ingredients, they can kind of release the agents during the processing of the material, and therefore they contaminate kind of our products, such maybe with TSE or BSE, and therefore this ADI free means that in our products there are no ingredients, is bones of animals or blood of animals. We all kind of let this out. We don't produce our products with such substances or materials. To go quick to BSE and TSE, which is an important point, and these BSE and TSE are prions, like proteins that can also develop and grow into the product still, because they are, let's say, not dead. So they could release the parasites and prions into your process. And therefore, it's very important that we don't use animal derived ingredients at manufacturing the products we make, the materials. The next point of industry standards is the ASME BPE. ASME stands there for the American Society of Mechanical Engineers, and BPE therefore is bioprocessing equipment. Now, a lot of people tend to compare the ASME BPE with the DIN, which we have in Europe, which I think in Europe most people know a bit more than the ASME. And it's partly true. You can compare ASME BPE with the DIN and ISO, but DIN and ISO is totally different in the structure they have. DIN and ISO is more like small parts with some information, while the ASME, on the other hand, is like much more detailed, a much bigger kind of standard, and very detailed. This you can see in their whole overview of. They have a kind of a catalog with nearly 350 sites, where kind of testing is described of materials, design of your gasket is described. As you can see here, they say how your contact surface finish should be, and a lot about sealing components. They have an own part which called SG, is for sealing components. So if we see here, the ASME BPE covers therefore materials, design, fabrication, inspection, testing, and certification. And again, to compare it a little bit with the DIN is also saying something about your materials, about your design, but not in the aspect the ASME BPE is doing it. So we can call the ASME BPE as kind of the leading standard on how to design and build equipment which we use for the production of biopharmaceuticals. To go a bit more into detail with the ASME BPE, if you think back about gaskets and the materials, there are some points out of the ASME BPE that are very important for us, for especially gaskets, of course. And that's the first one, the static seal performance, which we can, or we could describe as the dimension stability again. And the reference therefore says it's upon the installation of a hygienic static seal shall provide a substantially flush interface, which you could say it should be smooth and the sealing points should be met in this kind of. And therefore they have also intrusion categories 1 and 2. And these intrusion categories, they say they categorize materials into 2 parts, and they say the seals have a maximum intrusion or recess of a certain limit, which is for category 1 0.2 millimeters, no 0.6 millimeters. Sorry for that. And so to explain that quick, if we put our gasket into place, we tighten the clamp, our gasket moves for 0.6 millimeters inside or outside of our process. This gasket has the class or the category 1. Category 2 is then 0.2 millimeters, and therefore you can class all your gaskets after ASME BPE into 1 or 2. The next important part for gaskets are surface roughness, as I explained earlier, with the surface properties, if it's kind of smooth or not that smooth, and therefore there's an RA testing done for the contact surface. And there are also classes from 0 to 6. Class 0 would be no finishing requirements, so they would not say anything about the gasket surface. So if you have an RA of 1.5, it doesn't matter for this category. But the 0, the SFP, it is called 1, the contact surface, to 6, they would have strict maximum RAs of your surface in this kind. And the last part, or the last main point important for gasket and the materials, is simulate and combine CIP and SIP testing. In this part of the ASME, it is very, very detailed and very good explained how CIP and SIP the testing should be done and is working. And in this case, they really describe the complete testing procedure from point one in detail, with all the temperatures you need, with pressure ratings. And afterwards, it's also, they give you an example then how to test what you did with the CIP and SIP. So you can also, as it mentioned here, retorquing your clamps. Then it's a different test. If you don't do it and you just make CIP and SIP testing for that case, okay, sorry, CIP and SIP testing, and they describe it very, very detailed. It's always worth a look inside of the ASME BPE. So to summarize this part of certifications and regulations real quick, when you think back, Dominic showed us the overview about all these standards that you could have or could not have. So for us, it's very important for you to understand there are so many regulations, but we pick out what could be the best or what are the best for our products and for you, as you could use these products into or for your customers, and therefore. So again, to have all these certificates we saw on that slide is not important, or it's not recommended. We always should think and evaluate which are really the most important regulations and standards for us. And that's what we want to say or explain with this part when we were talking about European regulation, the American regulations, and about the Asian regulations in this point. So this is the industry standard parts from my side, and I thank you for listening, and I give back to Dominic now.
Okay, thank you very much, Chris, and thank you very much, Sasha, for sharing these details. Thank you, audience, for hanging in there. We exceeded a little bit. We thought we'd play it safe and schedule 2 hours. You can see there's just so much know-how and information that we wanted to share with you that we even exceeded these 2 hours. Feel free to address any kind of feedback in regards to content, style of presentation, or skills of our reference directly by mail. As announced in the very beginning, you'll receive a training handout, which are the slides and some of the documents that we referenced and went into, as well as a link to the recorded session, so that you might be able to have another look at any kind of detail that we presented to you, but also to maybe share it with anyone concerned within your company, any colleague that was not able to attend this webinar on short notice. In order to provide a little outlook to what we are doing, we finished this webinar today. This was the first session, and we would be very happy to welcome you back for the second webinar next Wednesday, which are gaskets and accessories, as well as connections in general, and a third webinar on Wednesday, May 6th, about the European hose range.